Hey guys, Mr. Breen here, and in this video, I'm going to talk about game theory and how it relates to market structures. Now, you've already seen some of this, but let's take a look at how perfect and imperfect competition contrast with each other in pricing decisions. So we're going to draw a supply and demand curve. Okay, so here's supply upward sloping, and here's demand downward sloping. And on this axis, we have price. On the x-axis, we have quantity. Now, in a perfectly competitive market, equilibrium will be right there, where quantity supplied and quantity demanded are the same. In this scenario, consumers are better off by roughly that much, and producers are better off by roughly this much. So that green area represents profits. Now, could these companies do better by acting differently? Well, what if they all acted like one company? So even though it's not a monopoly, what if they all acted like they were a monopoly? In this case, marginal revenue would look something much more like that. And the price, instead of being, output would be here because the supply is equal to marginal cost, and this here is our marginal revenue curve. Okay, they're going to set output where marginal revenue equals marginal cost, right there. But they're going to set price up to the maximum price they could get that would allow them to sell all of the good, which is way up there. So this would be the market price. And now the producer's benefit is all of this, all of that. Okay. And for consumers, their benefit is just up here now. Now we know that monopolists will act like this because they actually don't face any competition. So without regulation, they will do that. But what about the other kinds of market structure like perfect competition or monopolistic competition or oligopoly? What about them? Well, in perfect competition, there are too many firms for them to all get together and act like one firm, and the same goes for monopolistic competition. So we're kind of left with oligopoly. Okay, so to figure out how these businesses might work, I'm going to set up a demand table or a demand schedule. So instead of giving you a visual, I'm going to go back to a table, but I think it's going to be a little easier for us to look at this. And we're going to assume that whatever business this is, whatever industry this is, there are only two firms, just to make things a little simpler for us. Okay, so here's a graph that will work for us. So with these between these two companies, if they make 9,000, okay, they can charge a price of $1 and sell all of them. So again, this is like a demand curve, really. I'm just putting it out in a table. Okay, if they charge $2, they could sell a total of 8,000. If they charge $3, they could sell a total of 7,000. If they charge $4, they can sell a total of 6,000, and so on. Okay, so let's go ahead and work out all the total revenue. Total revenue. All right, so if they sell 9,000 at $1 each, that means they'll get a total revenue of $9,000. And if they sell 8,000 for $2 each, they'll have a total revenue of $16,000, $21,000, $24,000, $25,000, okay, $24,000, $21,000, and $16,000. Now, if they're going to end up sharing this total revenue equally and produce exactly the same quantity as each other, obviously they're best off here. They're going to share the highest amount of total revenue. Okay, but let's put this in game form. So we're going to get a 2x2 matrix here. As usual, we'll have company B up here on the top and company A over here on the left. Remember, company B's payouts are going to come second. This is not a zero-sum game. And let's say that they cooperate with each other and they decide to act like a monopolist together. They're not a monopoly, but they decide to act like that. And they're going to split a total output of 5,000. So each one produces 2,500. 2,500. That's how much they produce. And if they each produce 2,500, they'll split a total revenue of 25,000. So each one will get $12,500. $12,500. But what if company A decides instead to cheat a little bit and instead produce 3,500, add 1,000 to their production? Well, now the total production between 3,500 that company A produces and 2,500 that company B produces will be 6,000. So the only way they can sell all of them is if they sell them for the lower price of $4. Okay, so that means company A is selling 3,500 goods, units of their good at $4 each, and for that they're going to end up getting $14,000. And company B will sell 2,500 at a price of $4, and so they'll only end up getting $10,000. The same thing holds true if company B decides to cheat and produces 3,500 and company A does not. So now company B is the one that's cheating. Well, now it's going to be reversed. Company A will only get $10,000 and company B will get 14,000. But what if they both cheat? If they both cheat, that means they're each producing 3,500 for a total production of 7,000, and the only way they can sell all of them is if they sell them for a total of for a price of $3 each. So they're going to end up equally splitting $21,000. So each one will have a total revenue of $10,500. $10,500. Now notice something interesting here. The best off they can be together is up here if they maintain their little agreement, but each one has a strong incentive to break the agreement. Company A does better no matter what company B does. So let's say company B doesn't cheat. Company A is better off cheating. But let's say company B does cheat. Okay, company A is still better off cheating because either they're going to get 10,000 or 10,500. So this here, that's going to be the equilibrium. You know what this is? This is a prisoner's dilemma. And even if company B and company A negotiate together, they're still going to have strong incentives to cheat and compete against each other and end up with a lower price and higher production, which consumers like. So how can companies try to overcome this and earn a higher revenue and not compete against each other to the detriment of both, even though it is to the benefit of consumers? Well, they could try to make a legally binding agreement, a contract, right? They could, in other words, form a cartel or engage officially in collusion. But the problem is that these are illegal, highly illegal in most countries. Corporate executives would be in massive legal trouble just for discussing prices with each other, but even if they managed to hide their discussion, the contract that resulted would still be unenforceable. So if somebody cheated, the other person couldn't go to court and say, hey, they broke our contract, because the contract itself was illegal. But that doesn't mean there's no way around this. And one of the most important ways around this is called tit for tat, right? So if the other company cheats, you cheat. But if they pull back and say, okay, we're not going to cheat, then you don't cheat. Now this works because you're going to play this game over and over. In other words, it's not a one-shot event like the prisoner's dilemma. Okay, this is a repeat game. You're going to play it over and over again. Let's take a look at this payoff matrix again. Now let's say company B plays tit for tat. Tit for tat. So whatever company A did last time, that's what B is going to do this time. In other words, they'll reward them for cooperating and punish them for cheating. And A is always going to cheat. Always cheat. Okay. So, in this scenario, the first playthrough, company B is going to cooperate and company A will cheat. And company A will come away with some extra cash. But every next time, they're going to be in this box. Well, company A might notice that that's what company B is doing, that they're playing tit for tat. Even if they're not talking to each other, they might notice that, look, every time I cheated, the next time they cheated. But at first they cooperated, so maybe I should start cooperating. Okay, so eventually, if Company A learns the game that Company B is playing, they're going to cooperate, and Company B is playing tit for tat, so they're going to cooperate, and they'll end up in this box permanently. That means that even without talking to each other, they can still act like they're colluding, and this is called tacit collusion. They're not talking to each other, they're not explicitly colluding, but they're each playing this tit-for-tat game that benefits them without talking to each other.